Good evening, guys.
Good evening.
Can you hear me okay?
I
Hey,
hear
no, I
you.
can't.
Can you hear me?
Yeah, I hear you just fine, Gerald. How about you, John? Do a sound check.
Headset on.
Oh, now you see?
So
It's a
we're
good
up
thing
here
I
at the
asked.
Chabot Space and Science Center, keeping a close eye on the humidity. It's been teasing us this evening.
Yeah, there was a few minutes there where we thought it wasn't going to happen, but the temperature and the dew point both went down. And then the gap widened, and now we've got enough room for error here. So I think we'll be okay. So anyhow, thank you all for tuning in. I'm Rich Ozer, and we have Gerald McKeegan and John Curry, and you are viewing us from the 36-inch research reflector at the Chabot Space and Science Center. We have this virtual telescope program every Saturday night at 9 o'clock. And I want to thank all of you who have supported us and have donated to this program and others. It's how we keep things going up here. The Science Center is not yet open to the public, although we can't wait to open up again. We obviously have a little ways to go before that happens. So we depend on your donations. So keep them coming. We really appreciate it. I also want to thank Fremont Bank, who has sponsored this program and others. And it's through community support like that we'll be able to keep ourselves going and to offer all of this programming for STEM and other community program purposes. So anyhow, thank you. I guess we're going to get started tonight looking at the Orion Nebula. We might as well look at it while it's still here.
Yeah.
We only have a few more weeks where it's going to be viable to take a look. It's one of the most beautiful astronomical objects in the northern hemisphere sky. So why don't I share the screen and we'll start taking some shots of that. All right, there
Doing
we
that. If
go.
you happen to hear some music in the background, we actually do have an event going on up here at Chabot while we're doing our virtual program. Uh, a young couple got married up here. They had a very small scale wedding on site, and those folks are out on our observatory deck. We don't allow them inside the building, but they wanted to do something up here. So they're out on the deck, all socially distancing and everything, but they're having a good time. It's just a
Yeah.
very small group. And that's something we do. So if you've got a wedding or some small event that you want to do here at Chabot, we are available for those small events with a lot of limitations. So check it out. I see
Yeah,
the
thanks.
Orion Nebula.
Yep.
Yeah.
All right. You guys see that okay? Because I'm getting some weird flicker on one of my
No, it
computers
looks
No,
here.
it
great.
looks good from here.
Looks
Okay,
great.
very good. It must be the Wi-Fi connection for the second laptop. All right, good. So anyway, this is an extra short exposure, and the reason I did that is you'll notice that in the largest star here in the trapezium, you'll see a little bit of elongation. And also, the one just adjacent to it, you see a little elongation. That's because those are double stars. And the exposure isn't quite short enough. I ought to try a shorter one for just a few seconds and see whether I can get it to the point where it actually resolves the double stars. I don't think it will, but I want to give it a shot real quick here.
Yeah, you see the four bright stars there.
Yeah.
What you don't see with a camera view is there's a couple other stars within that tight cluster there. In fact, it's one of the ways that we gauge whether or not we have very good seeing conditions here at Chabot. If you can look into the trapezium and see not only the four bright stars, but both of those much dimmer stars, then we call it a six-star night, and that just means that the seeing is really good.
Well, this is interesting because as I drop the exposure time here, I'm able to see those extra two stars much more clearly. And I'm going to drop it another second here and see what happens. And maybe I could then magnify it. Now, if I zoom in a little bit, You could definitely see it on this one here. See how it's elongated, and
Yeah,
there's
yeah,
that other
little bulge
star.
right there, and
And there's a
the ones on the other
little
side.
bit here, a little bit here. The other image was a little better for that. If I
Can you
take,
show your zoomed in
yeah,
image, Richard?
yeah.
That might make it even more obvious.
Well, that's what I'm doing here.
Oh, okay.
So there, now you could see number 5 and number 6 barely.
Yeah.
Anyway,
Yep. So not a bad night.
no,
So for those of
pretty
you
good
not
night.
familiar with this object, this is called the Great Orion Nebula. It's a huge cloud of gas and dust, a little over 1,300 light years away. And it is a cloud that is condensing and forming new stars. So the four stars that you were just looking at there close up, we call those four stars the trapezium. They are very hot, very young stars. These are stars that are very massive, and they condensed early on when this cloud was condensing. Once they got hot enough, they actually began to emit a lot of ultraviolet radiation, which pushes the cloud away from them. But within the cloud, there are many, many more young stars that are still forming. The trapezium stars are very massive stars, or what we call type O and type B stars. And stars like that, very massive stars, although they form very hot and they shine very brightly, they don't last very long. These
Just an
clouds,
FYI here, guys. The humidity is creeping back up again. It's at 84.
Oh, is it?
okay,
Yeah.
all right, well, we'll go as long as we can.
Right.
Yeah.
Just
So,
want to warn you.
so these stars won't last very long. If they last 100 million years, that would be pretty long for them. Whereas our sun is already 4.5 billion years old, and it's got another 5 billion years or so to go. Um, so these stars are very young, maybe 1 million years old at the most right now, and like I say, they'll last for maybe 100 million years or less, and then they will swell up and become red giant stars, and then supergiant stars, and then eventually explode in supernovae. Um, because they are generating so much radiation, they are pushing the cloud away from them. And that has two interesting effects. First of all, it creates that pocket within the cloud that you can see. And so if you look carefully, you can actually see that this cloud is sort of surrounding the trapezium, kind of in a half circle. And we're looking into the pocket to see the trapezium. But the other thing it's doing is because it's pushing the cloud away from it, it's actually causing those parts of the cloud to condense. And so that process of actually pushing clouds and condensing those clouds because of the pressure actually stimulates even more star formation going on. So within the cloud, there are many, many more smaller, lower mass stars, stars that are maybe only the same mass as our sun, or maybe even less than the mass of our sun, that are still forming within the cloud. Eventually, they will all turn on, if you will, start fusing hydrogen and blowing the gas away from them. And eventually, this cloud will dissipate in millions of years.
Hey,
And we'll
Gerald.
have a,
We had a good question here. And what is the distance between the trapezium stars?
I read somewhere, I think the distance across the whole trapezium is only 6 or 7 light years.
Okay,
So they're pretty close together.
great.
Um, so anyway, this is common. This is how most stars form. In fact, probably how all stars form is in dense clouds of gas and dust uh, like this. Clouds, through some process, they start condensing, and as they condense, you get star formation within them. That star formation itself creates turbulence within the cloud that produces more condensation within the cloud, more star formation. And eventually you get anywhere from a few dozen to as much as 1,000 new stars forming out of a cloud like this. So this is how our sun was born.
Right.
Now you
So
notice,
the different colors that you see, I took a longer exposure here. I took a 30-second exposure to try to bring out some of these colors. And each of the colors that you see represents a different element. So the red is indicative of hydrogen gas, and the greenish bluish color is indicative of oxygen. And you could see that it's just chock full of both. The majority of the nebula, of course, is hydrogen, but the oxygen makes itself known because it glows far more brightly than the hydrogen does.
all right.
Cool.
So we probably ought to move on to our next
We
object
should.
here because our
Yeah.
humidity is creeping up and we want to get as many in as we can before the humidity knocks us out here.
Yep. I'm with you. So what's
So
next? Do you want to do
um,
the clown face?
Clown
Is that
Face
was?
Nebula.
All right. We took a look at this last week, but it's always fun to look at. It's really an interesting.
Yeah, you got a pretty good image of it last week too. So okay, so we're going to go ahead and slew to the Clown Face Nebula. I think I'm going to slew first to Pollux to get ourselves all lined up.
Okay. Let me get it on live view.
So the Cloudface Nebula is what we call a planetary nebula. It's actually the remnant of a dying star. It's in the constellation Gemini. Let me get this all centered up here a little bit.
Yep.
Oops, a little too much. There we go. All right.
There we go.
Okay, so now I'm going to slew to the Cloudface Nebula. Our telescope is computer controlled. So all we have to do is go to the computer, tell it where we want to look, and it does all the work for us. It keeps track of where the telescope is pointing, and when we tell it to go to another object, it figures out where it is in the sky and points the telescope.
All right. Are you there?
We're there.
All right. Let me start the shot.
So the Cloudface Nebula is what we call a planetary nebula, and the name is misleading because it has nothing to do with planets. Although there may be some planets up there, a planetary nebula is actually the remnant of a dying star. A long time ago, when astronomers first started seeing these things, they looked like they might be condensing clouds, sort of circular condensing clouds of gas. And so they thought maybe this was how planets formed. We've long since figured out what these really are, but the term planetary nebula has kind of stuck. So planetary nebula is gas expelled by a star as it approaches the end of its life. So you see that little green thing down there at the bottom, and you can see it has a bright center and then this kind of a puffy shell around it that has some shock waves in it if you look carefully. Um, this is gas that was expelled by the star. The star was once similar to our sun, but as it got old, it began to swell up, and some unusual processes were going on inside. Eventually, you get helium fusion going on, and the star swells up and gets bigger and bigger. And as it does so, the outer part of the star cools off and it becomes what we call a red giant. It's red because the outer outer shell of gas is cooled, so it gives it that reddish color. But it's also generating a lot of winds from the interior. Those winds are blowing the outer layers of gas off out into space and slowly eroding away the outer shells of gas of the star. And eventually the star loses quite a bit of its mass. And at the same time, things are going on down at the core. Helium fusion is going on. Depending on the mass of the star, there might be some fusion of some other heavier elements.
Mm-hmm.
but eventually, the most of the outer shell is gone. You've got just the core. The fusion stops. The core condenses to become a very small, very compact, very dense object called a white dwarf. White dwarf emits a lot of ultraviolet radiation. That ultraviolet radiation goes out and hits all that gas that was being blown off for hundreds of thousands of years and causes the gas to glow. It ionizes the gas and causes it to glow. And so that puffy cloud that you see is actually the ionized gas thrown off by the star while it was still a red giant.
And once again, you'll see it might be harder for the folks at home to see this, but on my screen, I could see that the ring of gas about halfway across the object is glowing with a reddish tint to it.
Right.
And that is indicative of the hydrogen, and the rest of it is a lot of glowing oxygen. Although there's hydrogen mixed in, the oxygen is overwhelming the hydrogen in terms of its brightness. I was showing this picture to my brother last week via a messenger, and he thought it looked like a padlock in the center of the
Ah,
nebula.
I
So
see that.
I think maybe we could start calling it the Padlock Nebula. Uh,
That won't offend anybody. That's a good
that won't
idea.
offend anybody. That's right. But the other thing I wanted to point out is the shape of this bright area in the center is a little bit unusual. It's asymmetrical. It has multiple lobes to it, and you'll notice when you look at other planetary nebulae, they tend to be maybe more circular or more symmetrical. And the reason for that is the white dwarf star in the center of this nebula is actually a binary system. And so the gravitational forces of the two stars orbiting one another causes disruption in the shape of the gas rings around the system and eventually distorts them. And that's why this one has such an unusual shape to it.
I hate to bear bad news, but we are at 86. Do we need to close, Joe, or push it? Jerem says it's 88 where he is, so it's going up
Yeah.
fast.
Well, I'll tell you what, we wanted to go to M82. You want to quickly go over there and take a
Yeah,
look at
All
that?
right.
let's do a quick galaxy, and then hopefully we won't regret it.
Yeah.
Yeah.
Yeah. Okay. So
And then I can close up while you guys talk if you like to.
Yeah, if it gets too damp in here, Gerald has to crawl into the telescope and dry it off with a Q-tip. And
Yeah, a 36-inch mirror with a Q-tip is
that's
really hard to
right.
do.
you guys are frightening.
That's right.
Okay. So we want to go to what? M81 or M82?
Either one. Let's do
Okay.
82 is more interesting usually. It's got that's the cigar, right?
Yes.
Yeah, let's do M82.
All right. Here we go. Going to be quite a slew here, so we may not hit it first time.
Yeah, we'll give it a shot. Do you want to stop at a star first?
Yeah. Hang on just a second here.
Go to Mizar or something. It's right
Yeah,
over there.
I'll put it on live view.
So when we make really long moves with the telescope, when we go from one part of the sky way over to another part of the sky, sometimes this telescope has a tendency to overshoot or undershoot. Actually, not too bad there.
No, that's pretty good. You're really close.
Okay, one more time. M82.
All right, let me
Okay,
know when
we
it's
are we
stopped.
are there.
All right, I'll start the shot. We'll do 30 seconds again. See what it does.
All right.
So, speaking of the planetary nebula and oxygen, one of the questions that was asked last week is where does the oxygen come from? Well, the interesting thing about fusion is when you start with hydrogen and hydrogen fuses, it fuses into helium. And when helium fuses, it fuses into carbon. And each of those elements end up in different kind of, you think of the core of a star as being like an onion, right? So each layer is a different element, but they mix a little bit. And so what happens is sometimes the carbon and the helium fuse, and you end up with oxygen. Oh, that's not a bad shot here. Hold on.
Oh,
Yeah.
Here we go. There we go. That's pretty good.
So the thing with this galaxy is we're seeing it sort of edge on. And it's about 12 million light years away. And it has a lot of dust in it. So you see dark streaks in it. That's actually dust lanes within the galaxy. We have the same thing in our own Milky Way galaxy. And those clouds of gas and dust, that's where all the new stars form.
Yeah, we got some color in there too. It's kind of nice.
Yeah, yeah.
Yeah, this one always seems to show up really well, and I think it's because it's a very high contrast galaxy. Others tend to just kind of look more like a blob. But you could see also these dust lanes,
Right.
and when you see these black areas in a galaxy, it's those are all clouds of dust that are possibly star forming material. And there's probably star formation going on in there. But to us, it just looks like like soot.
Right. And just like a cloud of smoke, it can absorb light and change the color of stars behind it. So you see
Right.
kind of toward the center, kind of as an orange colored area there. That's actually stars near the core of the galaxy. You know, look better before you did that.
No, I have to turn down
Okay.
the gain a little bit.
So stars near the core of the galaxy, the light from those stars is shining through that cloud, and the cloud is absorbing some of that light and changing the color to be that kind of orangish color. It's just like last fall when we had those big fires in the Bay Area and the whole sky turned orange because it was absorbing sunlight. And it preferentially absorbs the shorter wavelength light, the blue light, and so you just get the reds and the yellows coming through, and that gives it that kind of orange color.
from a great distance, those dust clouds can actually look like a gap in the stars. Could easily be mistaken for
Yes,
that,
you
but
know
it's
it's
not.
and sometimes when I'm looking at those types of dust clouds in our own Milky Way, it almost looks like there's a hole in the Milky Way, right?
Mhm.
Like you're
Yeah,
looking
yeah.
through it into deep space beyond. It gives you that illusion, but that's not at all what's happening. What's happening is there's this big blob of dark gas obscuring the billions of stars behind it, and that's kind of what you're seeing here as well. But it's fun to imagine it's the other when you're looking at it.
Right. In fact, 200 years ago, astronomers actually thought it was a gap,
Ah,
and it got the name the Great Rift. So
that's
if
right. Yeah, that's right. Uh, the what I find interesting about this one is usually when I look at a
yeah,
galaxy that's
okay,
got a
87. Yeah.
that are we at 87?
Yeah, we're at 87 here. We probably ought to start thinking about shutting down. Why don't we turn the lights on?
Oh, okay, I'll get that on.
Okay.
Oh, sorry, folks. It is what it is. One thing we can't control here at the Chabot Space and Science Center is the
We can do
weather.
the lights. Let me turn
There
those
we go.
on. Okay, tracking's off. So
Gerald, you want?
bear with us while we do this.
And I'll go grab that Q-tip for you, Gerald.
Yeah.
Okay, Cadillac Black which telescope are we looking through? We were looking through the 36-inch reflector telescope. In fact, let me turn the. I'm going to stop sharing the screen here for a sec, and you can see behind me the bottom of that telescope going to its park position. We're having to do this because the humidity got too high, and when the humidity gets too high, moisture forms on the primary mirror of the telescope. And we really don't like it to get wet inside the telescope because it leaves sleeks on the mirror and it allows dust and dirt to collect all over the surface and lowers the optical quality of the instrument. So,
That noise you're hearing is the roof closing. Our roof is
yep,
a rollback roof, so it's on
there it
tracks.
is.
Yeah, there you can see it.
You can see the roof closing.
Makes a lot of
We
noise.
always want to make sure the telescope is in the right position when we close the roof. It's very important. No one wants to fess up to having left the telescope in the upright position when the roof is closed.
Never happens.
It never happens. Well, not at this observatory, but it happened to me once. I did it once at
Oh yeah.
another observatory.
How long did
So,
it take you to get the dent out of the telescope?
fortunately, it left none.
Uh,
I was very lucky. It could have been much, much worse. And I was very lucky. But all of us make mistakes. It just goes to show you.
okay, well,
Yeah, there we go.
unfortunately, we had to shut her down before we could really do too much else. We're getting into galaxy season. Springtime is the galaxy season when we can see a lot of galaxies in the night sky. So we were kind of hoping we were going to be able to show you a few more galaxies, but I guess we'll have to wait till next time.
Well, at least we got one in.
Yeah. In fact, speaking of next time, a week from tonight, we're going to do something special. Our normal start time is at 7 or at 9 o'clock, but next week we are going to start at 7:30, and we're going to do something very unusual. It's called a Messier marathon. So Charles Messier was a French astronomer in the 18th century who was searching for comets, and the way he searched for comets was to point his telescope and scan the sky, looking for faint fuzzy objects. Now, his telescope was not as good as we have today. So he would look for faint fuzzy objects and then watch them over a period of time to see if they moved. And if you got a moving faint fuzzy object, that's a good indication that you found a comet. But what he was often finding instead of comets were faint fuzzy objects that didn't move. And rather than continuously rediscovering those same faint fuzzy objects, he decided to make a list of them. So he listed all of the faint fuzzy objects that he found in the sky that didn't move. And he ended up with a little over 100 objects on his list. Today, as far as I know, there are no comets named after Messier.
There are not. Yes.
But we still use his list. It's now
Yeah.
called the Messier catalog, and it has 110 objects on it. And every year in March, there's a period of time, it's only about a week and a half long, where conditions are just right. If you start right after sunset, as soon as it gets dark enough, you can view all 110 objects, but it takes all night.
Yeah.
So we call that a Messier marathon. It's quite a challenge. Some of those objects are hard to see, and depending on your timing, it may be just before dawn when you finally see the last one. So next week we are going to do a Messier marathon. We're going to start at 7:30 at night, and we will try to tag all 110 objects on Messier's catalog over the course of the night. And we expect to end sometime around 6 o'clock in the morning on Sunday morning.
if we don't fall asleep first.
Right.
Right.
I think more realistically, I've got some real questions on whether we're going to get the first ones and the last ones. Those are really tough, and we may not have enough clearance to. It may be beyond the limits of the telescope, but the idea is to at least get 103.
Right.
We might not get those last 7. Well, we'll have to see.
We'll
Now
try.
we're not doing this on our own, however.
Yeah.
We are
Yeah.
doing this in conjunction with dozens of observatories around the world. This is a project that's being sponsored by a company called Unistellar, a company that makes the EV scope.
Yep.
And several of the people in the Unistellar company are also members of the SETI Institute. So SETI and Unistellar are sponsoring this event, and they are promoting it. And we are going to be one of dozens of observatories around the world that are going to try to do a Messier marathon. Now, some of them aren't quite as ambitious as we are. Some of them are going to do what they kind of call a half marathon, where they're going to try to find only half the objects. We've got a big telescope, so why not go for the whole enchilada? So if you want to join us, if you don't mind staying up all night long, starting at 7:30 next Saturday night, we will do a Messier catalog, or a Messier marathon, rather.
I got to mention, in Paris, the French held Charles Messier in very high regard, and the Paris Observatory is a half block away from the corner of Messier and Cassini. And you can get a cold beer and a delicious sandwich on the corner of Messier and Cassini, because I've done that. I just remembered that as you were talking about Messier.
I have a trip hopefully planned to France in June. Maybe I'll try to do that.
You should try to do that. The observatory was closed when I was there, but I don't know when they offer tours or anything like that. But it's fun to walk.
You can always get a beer, right?
Right.
You can always get a beer. That's right.
We have an interesting question here from Margot. They read a New York Times article about the moon having a comet-like tail comprised of sodium. I didn't hear about that.
I read that. I glanced at that article and I thought, this is very strange. Gerald, did you happen to see that?
This is the first time hearing about it.
Yeah.
She says she asks if it's something visible via Nellie. I suspect it's only visible with a spectroscope.
Yes.
Right.
Otherwise, much larger telescopes than Nellie have been trained on the moon for a century, and it's not anything that can be seen visually.
Yeah. So this is probably outgassing caused by differential heating of the surface and things like that. I'm just guessing here.
Yeah.
But that's kind of interesting. I'll have to do a little.
It is, isn't it?
Little research on that.
There was another question that was earlier when we were talking about oxygen, the formation of oxygen in planetary nebula, not in planetary nebula, in stars being made visible in planetary nebula. And somebody asked, well, where did the oxygen in our atmosphere come from? So when a first generation star, which, to make things more confusing, is called a population 3 star. Astronomers count backwards, and the rest of the world counts forwards. So population 3 stars are the oldest stars. Population 2 stars are the next generation. Population 1 stars are the most recent stars that have been formed. And our star is a population 1 star. And the cloud of gas that formed our sun had oxygen in it left over from other stars that contributed that gas to our region of the galaxy. So some population 1 star and some population 2 stars gave up some of their material in their life cycle to allow the population 1 stars to form with a higher amount of oxygen than either of the first two populations. And furthermore, the rest of that molecular cloud, what's called a molecular cloud, contributed to the formation of planets and asteroids and comets and all the other material that goes along with a star. And when the Earth formed out of the rock and gas that was in orbit around the sun, it picked up oxygen along the way. And but also life contributed heavily to the production of oxygen. It's
Right.
not just stuff that came from space, right? Because the Earth's atmosphere was fairly oxygen poor until life came along, and plants in particular
Yeah.
converting carbon dioxide to oxygen
Yeah.
and
And
turning it
that
into
only
what's called a
happened.
reducing atmosphere.
Yeah, that only happened about 600 million years ago. So
Yeah, yeah.
planet's been around for 4 billion years,
Hmm.
but it was only 600 million years ago that plant life started converting carbon dioxide into oxygen.
Right. But there was some percentage of oxygen present before before that, because there was water from comets and all this, and that's got an oxygen component too. But in terms of it being in the atmosphere at the concentration that we see now, that's very much due to life, not due to the history of star formations.
Hey,
So,
we
so
have an
Richard,
interesting. Oh, go ahead. Joe.
Richard, if I understand you correctly, each generation of stars is dirtier than the previous generation.
Right. But here's something else that astronomers do. And I'll tell you, astronomers have a weird way of thinking and speaking because they talk about metallicity of stars, right? And when I think of a metal, I think of iron and aluminum and beryllium and things that if I whack the wall, it makes a hole in it, right? That's a metal to me, right? But astronomers call anything heavier than helium a metal when it comes to discussing stellar evolution and star formation. So, population three stars, the oldest stars in the universe, they had nothing to work with except for hydrogen, right? So, they were purely made of hydrogen, and that hydrogen then fused into helium, carbon, and oxygen, and ultimately into iron to some extent. And then those stars that went supernova in a very short period of time, because of all that release of energy, we're able to fuse elements into the real heavy stuff, like lead and uranium and gold and all the stuff that's further down at the periodic table. Most of the stuff in the periodic table comes from supernova, right? Because there's no other way for that stuff to form. But the population two stars, and then later the population three stars, their clouds of gas that formed them were polluted with all of these other elements that came out of the generations of stars before them. So yes, absolutely, we came from a dirtier cloud, which gave us all the things that we like to collect here on Earth, right? We wouldn't have any of those really heavy elements if we were somehow part of a population three
So
Well,
system.
like
don't
the
don't forget the
calcium in our
neutron star
bones.
collisions
Yeah,
too.
yeah,
Yeah,
calcium in our
yeah.
bones.
Neutron
Yeah,
star collisions also produce a lot of heavy
right,
elements.
exactly.
Yeah.
Yeah.
So somebody asked what galaxy we're looking at just before we closed. That was the galaxy M82, also known as the Cigar Galaxy.
We did get an interesting question about the Messier Marathon.
Yes.
Will we be able to show the view from other observatories during the Messier Marathon? Well, we don't have control of that, but I'm sure
Right.
there will be other websites available that you could go to.
It may be that there are some breaks during a Messier marathon where if you've stayed on schedule, that you got like an hour until you can find the next thing,
Uh,
and that we may be able to take a look at see what other observatories are doing at that point. We'll kind of have
Yeah.
to play it by ear.
Yeah, I'm not sure how they're going to, they being Frank's organization there, how they'll coordinate everything. They may have a site to kind of gather all the data.
It's kind of what I'm thinking is they'll have a central site as well where people can browse from one program to the next. I don't know. So, question:
see.
What are these Messier objects? Well, there are a variety of things, right? So there are some galaxies, there are some planetary nebula, there are some nebula, there are even some double. There's one that's just a double star. and it kind of fooled Charles Messier at the time. He thought there was some glow around it, so he put it in his catalog. And you look at it, it's just two stars. But it's just anything he found that was seemingly unusual that he felt belonged in his list of non-comets. Are naps allowed?
Naps allowed.
Yeah, absolutely.
No.
Absolutely. Naps
No.
are always allowed. Yeah, we're going to have a betting pool on how many people are watching at 3 in the morning. But Gerald pointed out that since it is a worldwide event, we may have people tuning in from other parts of the world because our program will be running at 3 in the morning here at Pacific time, but it may be daytime. So it will be daytime somewhere else, and others may want to tune in during the day to see what we're up to. So you're not obligated to watch us for 12 hours, but
Wait a minute.
you're welcome to.
If we see your name at the beginning, we expect to see it there at the end.
That's right. There'll be a test. There's a test at the end. Yeah, Marlene, if we do get those links, we're going to be obviously looking at this during the week. We haven't gotten a huge amount of information yet from them. We'll go ahead and make sure that any links that are relevant to what we're doing are made available to you. By all means, we'll do that. Hopefully, in the next day or two, we'll have that all figured out.
There's a question. I think this goes back to the Clownface Nebula, or the Lock Nebula, whichever that was.
Yeah, the Padlock Nebula.
Yeah.
Padlock Nebula.
How close are the two binary dwarf stars?
They're really close. They wasn't determined that there was a binary until fairly recently. And I can't give you a distance. All I can say is that they're very tightly coupled.
And is one much larger than the other?
I don't think they have a huge size difference. I have to do more reading on that though. But from what I recall reading is that they're very close, but not a huge size difference.
So in reality, more than half the stars you see in the night sky are actually binaries or multiple star systems. So it's actually quite common.
But with white dwarfs, they're small to begin with, only planet size. So a second one, I'm curious too as to what the size would be, or the size difference.
I'll see if there is. Dredge up that information in the coming week and talk more about it next week, maybe.
I'll do some digging.
Richard, do you happen to know off the top of your head which Messier object it is that's actually just a binary star system?
Give me a minute or two, and I'll find that out.
There's a chart on the wall over there.
Yeah, I forgot. I left my book of Messier objects at home. I was going to show it to you tonight. And
yeah, I'm just going through the list here, and I don't see one that meets that criteria, but we'll find out next week.
Yep.
All we got to do is make sure.
Oh, there it is. It's M40. It's also known as Winnicky 4. It's a double star located in Ursa Major.
Oh.
Well, we're going to look at it anyway.
Yeah, of course we will. Take photographs of it and turn it into a poster.
Here's somebody that doesn't want to stay up all night. Will the Messier Marathon be recorded and posted later. I
Well,
think we'll try to do that. It's
one
going
of
to be
the things we don't know is what happens with Facebook recordings once you cross 11 hours.
yeah, yeah.
We really don't know, and we hope that it will be on there. We hope that we don't fill up Facebook's server and YouTube's server. I know Zoom only allows you a 2 or 3 hour recording, but I think it'll probably stick and it'll just be there. So the answer is
there we go.
yes.
That's M40 right there.
Yep.
Okay.
Oh, thank you.
Good.
That was it. Yeah.
Good snatch there.
All right, that's one down. 109 to go.
Can we start now?
Yeah. Well, I tried this once before, Gerald, with actually the first time I tried to do a Messier marathon, it was with a telescope, an automated telescope and a camera, which is really cheating because most people do Messier marathons with a push-to telescope, like a Dobsonian telescope.
Oh.
And part of it is you have to star hop
Oh boy.
from Messier object to Messier object. And that kind of that's a real challenge, because you have to find all of these objects in what might be light polluted skies. So we're going to be cheating a little bit, but on the other hand, we're not going to be spending a lot of time trying to find things because we'll spend our time showing them to you instead. So I think it's a reasonable trade-off.
Yeah.
So I was thinking of bringing my CCD camera.
Yeah, you should. We should put that on one of the. We should put that on one of the scopes and put the DSLR on the other, and then we can, switch between them.
Yeah.
Oh, there we go. There's
There's
the Black Eye
M64.
Nebula.
We got two of them.
No, that's the black guy.
Oh, the black
Black
eye.
Eye.
Yeah.
M64, the black eye.
Yeah. Yep.
Can we call it the black eye now?
Yeah, it's okay.
I think that's all right.
All right.
All right.
Well, we apologize for the humidity.
Yeah.
That's how it goes up here sometimes. We had a lot of rain last night, so the ground is still pretty wet. And as it got cooler, the humidity went up, and now we are up at 89%, which
has not gone down again. So.
It's probably going to go higher before the night is over.
Yeah, we did the right thing by closing up. Oh, Sabina asked, do we do them in order of Messier number or by proximity?
Oh, no.
It has to be by proximity. We have to start on the westernmost part of the sky and then work our way east. And then try to get them as they rise in the east,
right.
Ending at the very end with the objects that are just rising as it starts getting bright on the horizon.
Yeah, so when we look at objects in the sky, we have a coordinate system that we use to map the sky. And it's similar to the GPS coordinate system that you use on the ground. So the east-west coordinate is called right ascension. The north-south coordinate is called declination. And what we're going to do is do these in order by right ascension. So we'll start with the one that we can see soonest right after sunset and work our way to the east in right ascension order. Right ascension increases as you move eastward. So that's how we will do it, and just continue working our way across the sky. Our viewing close to the horizon here is not really good because we are in the Bay Area and we do have a lot of light pollution. So there may be a few objects low in the sky that we won't be able to see, but we should see most of them. And that's part of the fun is to see how many you can tag.
That's right.
So
somebody wanted to know how old Nellie is.
Yeah, Nellie was
20 years old, right?
No.
19 going on 20.
19
yeah.
years old. All right.
Actually,
Nellie was
18. Built in 2003.
2003. So yeah, you're right.
All right, there you go. And oh man, Richard just said that it's only 56% humidity at the bottom of the hill. Well, it's coming
Thanks,
for you, buddy.
thanks for rubbing it in.
Yeah.
Yeah.
Thanks for
Thanks,
rubbing
man.
it in.
Thanks, man. We needed to know that. Yeah, old enough to
Old
vote.
enough to vote.
Nellie's old enough to vote. No, Jerm, we did not call it the black eye. We called it the black eye galaxy.
Like when you get hit in the eye really
Yeah.
hard,
It
get a
looks
black
like
eye.
it looks like it got punched in the eye. How does the 36-inch telescope? Yeah, the Ravi, the other telescopes here at Chabot are not reflector instruments; they're refractors. They're more old school, long focal length refractor telescopes. They're lenses, not mirrors. One is a 20-inch, the other is a 6-inch, or excuse me, an 8-inch, and designed more for planetary observing than deep sky observing. Whereas Nellie is absolutely a deep sky instrument because of its large aperture.
Those older telescopes, by the way, were built in 1915 and 1883, respectively, there. So they're a bit older.
A bit, but working very well.
Yeah.
Yeah, kind of amazing actually how well they do work.
Yep. Well, we take good care of them, right? How about other observatories? Well, it's hard to say. They're really all over the map. I mean, if you go to the Lick Observatory, it's a combination of long refractor instruments, kind of like what we have here in the historical instruments, as well as more modern, large reflector telescopes. All observatories that are built today are reflector instruments. Nobody builds big refractors anymore. They're not. There's no point to it. So the giant Magellan telescope that's being built, and the new one's being planned for Hawaii, and the Keck, and the all the other large instruments in Chile and Hawaii and in the California mountains as well. They're all reflectors.
How often do we clean Nellie's mirrors? Well, if Gerald isn't doing it with a Q-tip often enough, then we try to do it once every 2 years. Try to. We don't always manage to stay on that schedule, but we try.
Yeah, it's not an easy task.
No, I mean a lot of observatories kind of take the approach that hey, when the mirror gets too dirty, it's time to re-illuminize the mirror, and they take it out and they bring it to the illuminizing chamber. They strip the coating and they put a new coating on it. That's a big deal for us to do that. It's been done before. We don't want to have to do it very often. It's expensive.
Yeah.
But it's fun.
Yeah, I guess it's fun.
Fun
As
taking
long
the
as
telescope apart.
as long as nobody drops it.
Yeah, it's fun taking it apart, but then putting it back together again, that's always the problem.
Yeah. Yep.
Getting it all perfectly lined up properly.
All right. Well, I
think that's it.
I think we've pretty well exhausted what we can do tonight. We apologize for the weather kind of knocking us out here a little sooner than we wanted, but
Yeah, we had fun anyway. At least we got to show a few things.
Yep. Join us again next week. Again, we'll start at 7:30 p.m. Pacific time, and that'll be on Saturday, the 13th, March 13th, which will still be standard time. When we're finished on Sunday, it will be daylight saving time. So not only are we going to stay up all night, but we're going to lose an hour of sleep in the process.
Oh my God, that's going to be so confusing. I had no idea. Now I'm having second thoughts. All right. Well, anyway, good night, everyone. And thank you for tuning in tonight. And we'll see you next week.
Oh, thanks for joining us. Good night.
Yep. All
Good night.
right.